Welcome to a justification of L'Hopital's rule using tangent lines when we have a limit in the indeterminate form of 0 divided by 0. L'Hopital's rule states the limit as x approaches c of f of x divided by g of x equals the limit as x approaches c of f prime of x divided by g prime of x when we have a limit in the indeterminate form of 0 divided by 0 or any of the indeterminate forms shown here. But in this justification, we are only considering the case of the indeterminate form 0 divided by 0. To begin, we assume f of x and g of x equals 0, f of x and g of x are differentiable, and g prime of c doesn't equal 0. Let's begin by developing the idea by analyzing this graph, where the blue curve is f of x and the red curve is g of x. And the blue line is tangent to f of x at x equals c, or the point c comma 0, and therefore the slope of the blue tangent line is f prime of c, and the red line is tangent to g of x at x equals c, and therefore the slope of the red tangent line is g prime of c. From here, let's find the equation of this blue tangent line. Using point slope form, where the form y minus y sub 1 equals m times the quantity x minus x sub 1, notice how the point is c comma 0, and the slope m is f prime of c. And therefore the equation is y minus 0 equals f prime of c times the quantity x minus c. Simplifying, the equation of the tangent line is y equals f prime of c times the quantity x minus c. Similarly, we could find the equation of the red tangent line. The only difference is the slope would be g prime of c. So the equation of the red tangent line, which is tangent to g of x, is y equals g prime of c times the quantity x minus c. From here, remember a tangent line is a good approximation for a function as long as we are near the point of tangency. So now going back to the limit as x approaches c of f of x divided by g of x, if we use the tangent lines as approximations for f of x and g of x, we could say this limit is approximately equal to the limit as x approaches c of f prime of c times the quantity x minus c, which is the tangent line to f of x at x equals c, divided by g prime of c times the quantity x minus c, which is the equation of the red tangent line to g of x at x equals c. Once we have it in this form, notice how we have the quantity x minus c divided by the quantity x minus c, which simplifies to 1, which gives us the limit as x approaches c of f prime of c divided by g prime of c, which just equals f prime of c divided by g prime of c. This is what we needed to show because remember, we find f prime of c by evaluating f prime of x at x equals c, and we find g prime of c by evaluating g prime of x at x equals c. And therefore we have our justification. The limit as x approaches c of f of x divided by g of x equals the limit as x approaches c of f prime of x divided by g prime of x, which equals f prime of c divided by g prime of c using the method of direct substitution. Again, this is not a formal proof of L'Hopital's rule, but it does use tangent lines to justify L'Hopital's rule when we have the indeterminate form of 0 divided by 0.